Hello students, in last video we discussed the electronic configuration of 15 group elements, some general properties of 15 group elements, occurrence and physical properties. In this video I am going to discuss the chemical properties of 15th group elements. Chemical properties of 15th group elements. In that, first point, action with hydrogen. Action with hydrogen. What happens when 15th group elements reacts with hydrogen? Remember, nitrogens or 15th group elements when react with hydrogen at the time hydrides are formed. Usually covalent hydrides are formed. Remember, when 15th group elements react with hydrogen at the time covalent hydrides are formed. Yes, what are those hydrides? See here. NH3, PH3, ASH3, SBH3 is ultimate hydride. Next another one, BiH3. This NH3 is called as, you know, this is ammonia and this is phosphine and arsine. Yes, the 2 points, 2 very important points comes here. What are those here? The thermal stability. The thermal stability of respective hydrides. The thermal stability of respective hydrides decreases. The thermal stability of 15th group elements with respect to hydrides down the group decreases. Remember, this is very important. The thermal stability of these hydrides decreases down the group. What are the 15th group element hydrides? NH3, PH3, ASH3, SPH3, BiH3. These hydrides thermal stability decreases down the group. Remember, thermal stability of respective hydrides decreases down the group. Therefore, it can be written as NH3, thermal stability of ammonia is greater than, PH3 is greater than, ASH3 is greater than, which one? SBH3 greater than BiH3. It shows the thermal stability of respective hydrides of group 15 elements decreases down the group. Next, another one point. Reducing character. Reducing character of hydrides of 15th group elements. Remember, reducing character of hydrides of the group 15 elements increases down the group. Reducing character of hydrides of 15th group elements increases down the group. Therefore, it can be written as Therefore, it can be written as NH3 less than PH3 less than ASH3 less than SBH3 less than DIH3. These 2 points are very important. Here, please remember this. If you come to the point of thermal stability, it decreases down the group, and reducing character increases down the group in presence of hydrides of the group 15 elements. Yes, please remember. Next, let's go to the next concept. Second point. Action with oxygen. Action with oxygen. What happens when 15 group elements react with oxygen? Remember, students, when 15th group elements react with oxygen, at the time the possible products like M2O3 and M2O5, when 15th group elements are react with oxygen, at that time the possible products like M2O3 and M2O5 are formed. Yes, important points related to this concept is, in that first one, the acidic nature or acidic character of oxides of 15th group elements. Oxides of 15th group elements decreases down the group. Remember, this point is very important. Acidic character or acidic natures of oxides of 15th group elements decreases down the group. Remember this point. And one more point. Greater the oxidation number or greater the oxidation state, greater will be the acidic nature. Greater will be the acidic nature. Yes, these are two important points related to the action of 15th group elements with oxygen. Yes, if you know this concept, then it is very easy to answer the two questions. What are those questions here? In that first question, between N2O5 and P2O5, dinitrogen pentoxide and diphosphorus pentoxide. Between N2O5 and P2O5, which one is more acidic? Which one is more acidic? Yes, N2O5 and P2O5. You know these concepts. Acidic nature of oxides of 15 group elements decreases down the group. Greater the oxidation state, greater will be the acidic nature. Apply these points to here. Yes, check the oxidation number of nitrogen here and phosphorus here. Yes, here ending that N2O5, dinitrogen pentoxide, oxygen minus 2, 5 into minus 2 is it minus 10, and overall equal to 0 means the value of N2 is plus 10, but the oxidation state of only one nitrogen is plus 5. Oxidation state of nitrogen in N2O5 is plus 5. Similarly, here phosphorus also having plus 5 oxidation state. Yes, here both the given components having plus 5 oxidation state. Then which one is your answer? What is our question? Between N2O5 and P2O5, which one is more acidic? Yes, apply this point. Acidic nature of oxides of 15th group elements decreases down the group. Yes, if you move down the group, first comes nitrogen and the next phosphorus. Yes, therefore our answer is N2O5 is more acidic. N2O5 is more acidic. N2O5 is more acidic because compared to P2O5, N2O5 is in small size, or atomic size of this one is small. Therefore, N2O5 is more acidic. Next, another one question. Between P2O3 and P2O5, between P2O3 and P2O5, which one is more acidic? Which one is more acidic? Calculate the oxidation number of phosphorus in both the given compounds. Here, oxygen is minus 2, 3 into minus 2 it is minus 6. Therefore, P2 is definitely plus 6, but P is oxidation state. P2 oxidation number is 6, but only one phosphorus, P's value is plus 3. Here already calculated plus 5. Phosphorus oxidation number is plus 5. Yes, between these two, this one has higher oxidation state. According to the concept, greater the oxidation number, greater will be the acidic nature. Therefore, between these two, P2O5 is more acidic. P2O5 is more acidic. Yes. How to calculate oxidation number? See here. Here the given examples are P2O3. ಇಲ್ಲಿ ನೋಡಿ ಇದನ್ನ ಆಕ್ಸಿಡೇಟ್ ಫಾಸ್ಫರಸ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ನಾವು ಅನ್ನೋದನ್ನ ಸಿಂಪಲ್ ಆಗಿ ನೀವು x ಈ px 2 into x plus 3 into minus 2 equal to 0 ಈ ಪದ್ಧತಿಯಿಂದ ಹಿಂದೆ ಮಾಡಿದ್ವಿ ಹೌದಾ ಅದಕ್ಕಿಂತ ಸಿಂಪಲ್ ಆಗಿರೋದು ಇಲ್ಲಿ ನೋಡಿ overall sum of this is equal to ಏನಿರ್ತದೆ 0 ಹೌದಾ ಅಂದ್ರೆ ಈಗ ನೋಡಿ ಈ ಆಕ್ಸಿಜನ್ oxidation state is -2 3 into -2 ಇಲ್ಲಿ ಸಣ್ಣದಾಗಿ -2 ಅಂತ ಬರ್ತಲ್ಲ 3 into -2 -6 next when it becomes equal to 0 ಯಾವಾಗ ಇದು 0 ಆಗ್ತದೆ ಅಂದ್ರೆ ಈ ಹಿಂದಿನ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಆಗಬೇಕು +6 +6 -6 equal to 0 ಓಕೆ p2 ವ್ಯಾಲ್ಯೂ +6 ಬಟ್ ನನಗೆ p2 ಬೇಡ p ಅಷ್ಟೇ ಬೇಕು ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಎಷ್ಟಾಗುತ್ತೆ +3 ಆಯ್ತಲ್ವಾ ಸೋ ಫಾಸ್ಫರಸ್ ದ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ +3 ಆಯ್ತು ನೆಕ್ಸ್ಟ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ P2O5 ಅದೇ ತರ ಮತ್ತೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಯೂಶುವಲಿ -2 5 into -2 -10 ಯಾವಾಗ ಇದು ಟೋಟಲ್ ಸಮ್ 0 ಆಗುತ್ತದೆ ಅದರ ಹಿಂದಿನ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಏನಾಗಿರಬೇಕಂದ್ರೆ +10 ಆಗಿರಬೇಕಾಗಿದೆ +10 -10 equal to 0 ಹಾಗಾದ್ರೆ P2 ವ್ಯಾಲ್ಯೂ +10 ಆದ್ರೆ P ಎಷ್ಟಾಗಿದೆ ಅದು +5 ಅಲ್ಲ ಸೋ ಇದರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ರಿ ತುಂಬಾ ಈಜಿ ಆಗ್ತದೆ ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ನಮ್ದು ಥಿಯರಿಟಿಕಲ್ ಕಾನ್ಸೆಪ್ಟ್ you know 2 points greater the oxidation number greater will be the acidic nature ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿ ನಿಮಗೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ between P2O5 and P2O3 which one is more acidic P2O5 is more acidic due to the increase in the oxidation number increase will be the or greater the oxidation number greater will be the acidic nature. Yes, next point. Third point, action with halogens. Action with halogens. Yes, students, remember, when the nitrogens or 15th group elements react with halogens, at the time the possible products like MX3 and or MX5, when 15 group elements react with halogens, at the time the possible products like MX3 or MX5 is formed. But one thing is very important, nitrogen, it cannot form pentahalides because it do not contain d orbitals. Remember, this point is very important. Nitrogen do not form pentahalides because the absence of d orbitals. What happens when 15 group elements react with halogens? At that time, the products like MX3 or MX5 are formed. If you take an example, PCl3, PCl5, these are the halides of phosphorus. Yes. Next, another concept. Anomalous properties of nitrogen. Anomalous properties of nitrogen. Anomalous of nitrogen. You know, the first member of 15th group elements is nitrogen. First member of the 15th group element is nitrogen. This nitrogen has its own properties related to or when you compare with other elements present in the same group. ಈ 15ನೇ ಗ್ರೂಪಿನ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆ ನೈಟ್ರೋಜನ್ ನ ಕಂಪೇರ್ ಮಾಡೋದಾದ್ರೆ ನೈಟ್ರೋಜನ್ ತನ್ನದೇ ಆದಂತಹ ಕೆಲವು ವೈಶಿಷ್ಟ್ಯತೆಯನ್ನ ಒಳಗೊಂಡಿದೆ. ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಅಂದ್ರೆ 15ನೇ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನ ನೈಟ್ರೋಜನ್ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ ನೋಡಿದಾಗ ನಮಗೆ ನೈಟ್ರೋಜನ್ ಉಳಿದ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗಿಂತ ವಿಭಿನ್ನ ಆಗಿರುವುದು ಕಂಡು ಬರ್ತದೆ. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನಾವು anomalous properties of nitrogen ಅಂತ ಕಲಿತಾ ಇದ್ದೇವೆ. Okay, what are some properties? Means anomalous properties of nitrogen. See here, in that first point is small in size. Is it right? Small in size. If you move down the group, what about atomic size? Increases. You know, because of that point, write one point. Nitrogen is in small size compared to other elements present in same group. Means 15th group. Next, high ionization energy. Ionization energy of nitrogen is high compared to other elements. High ionization energy. Next, high electron affinity. Next, absence of d orbitals. Next, another point, high polarizing power. High polarizing power, etc. These are some anomalous properties of nitrogen. Let's come here. Small in size compared to the other elements present in a 15th group elements, nitrogen is small in size. And it has high ionization energy. Know what is ionization energy? It is the amount of energy required to remove an outermost electron of an isolated gaseous atom. And with a high electron affinity, it is the amount of energy released when an electron added to the outermost shell of an isolated gaseous atom. These ionization energy values, electron affinity values are higher when you compare with the other elements present in a same group. And when you write the electronic configuration of all these elements in 15th group elements, we observe the absence of d orbitals in nitrogen. And high polarizing power. Nitrogen having high polarizing power. What is polarizing power? It is the ability of cation to destroy the anion. Okay, remember these points. Okay, in this video we discuss the chemical properties of 15 group elements.